Welcome to another online lesson. This is Mr. Palmer, and today I'm going to be going over the acceleration practical, a key practical for GCSE physics, and this is one of the 6 required practicals you must know. Now, for this, we're going to be using our acceleration equation, and we're also going to be linking to the speed equation. So for acceleration, remember that is change in speed divided by time, whereas for speed, that is distance divided by time. Now, the reason we need to use both equations is we need to first of all work out the time it takes for this trolley to go from the top of a ramp to the bottom of a ramp, so we can work out the total time this trolley has travelled. We then have to work out its change in speed, because we're trying to work out this trolley's acceleration. And to do that, we need to know the speed at the top, and then the speed when it gets to the bottom of a ramp. And to do that, we need to do this distance divided by time calculation. Now, when it comes to this, we've got one bit of help. We're trying to calculate the change in speed from a trolley at rest. Now, what speed is something that's travelling at rest? 0 meters a second. So at the start, it's not travelling at any speed. When we let it go, it's going to get faster and faster and faster. And so we're going to need to somehow record our speed down here. Now, the way we do this is really simple. We get a ruler, something like a 30 centimetre one, and a stop clock. What we're doing down here, we're going to be allowing the trolley to come down to get faster, and we're just going to record its speed in the last moment. And the way we do that, we get our distance, say 30 centimetres, and we record the time it takes to go this 30 centimetres, and then we can get the trolley's new speed. So we'll do the start. We'll have a trolley ready, and we're going to start with work out its speed when it gets to the end of the ramp. So I'm ready with my stopwatch. I'm going to start the stopwatch as soon as a trolley gets to the start of the ruler, and then I'm going to finish when it gets to the end of the ruler. So are we ready? 3, 2, 1. So I got a time there of 0.44 seconds. I'm going to record that. Now, if it had a time of 0.44 seconds, how can we work out the speed at the bottom? That's right, we do the distance, 30 centimetres, divided by 0.44 seconds. So we're going to be doing that, and we're going to know our final speed. Would it be accurate, though, if we only did this once? No. So what we're going to do with these to make it more accurate, we're going to take repeats. So we'd repeat this experiment multiple times, and each time we'd repeat the timing of this bottom step at least 3 times. Once you've done that, you can calculate a mean by adding the 3 numbers up and then dividing by the total number of readings, 3. So that would be how we get our final speed. As I said, we've got our starting speed, 0 meters per second. So the other measurement we need to make is the total time it takes to go from the top of a ramp to the bottom of a ramp. Now, again, this time, we're going to get ready with our timer, make sure we've reset it. Then we are going to get ready with our stopwatch. As soon as we let the trolley go, we're going to start the stopwatch. As soon as it passes this point, we're going to stop the stopwatch. So, 3, 2, 1. 2.85 seconds. That's my total time. So I've got a total time there. I've just got that. So we've got then our change in speed. We've got then our total time. So we can then make sure we can calculate that acceleration. And again, we don't just want to do that once. We want to repeat that 3 times. So once we've done that, once we've done it 3 times and got our sets of measurements, we can calculate the acceleration for this particular height. So the way we do that, we do total time, we do change in speed, and then we divide it by the total time, and then we've got our first acceleration results. Now, before we want to also make sure we're doing this as a fair comparison. So we need to make sure when we carry out this experiment that we keep certain things the same each time. So one thing we're going to do is we're going to make sure that we have it across the same distance. So here, I've drawn a line on the board, and that's starting there, and then I carefully measure the distance so that it travels each time a total of 2 meters. I'm looking at this experiment to see how the ramp height affects acceleration. So I'm also going to measure carefully the height of the ramp. Once I've done it for this height, I can then change the height and carry out the experiment again and again. Now, this is an okay way to carry out this experiment, but I'm sure you can imagine it's got some issues. And this is something which comes up a lot in GCSE experiments, how to make them more accurate or more reproducible. Now, one big issue, we're using a stopwatch. Now, when I let this go, who is it who's starting the stopwatch and who is it who's stopping? Me. Am I going to be quick? Probably not. If I did this multiple times, chances are I'll get a slightly different result every single time. I'm not the quickest person on the planet. I am not a computer. I cannot do things the same every time. So we've got this risk of human error. Now, the way we get around this is by using a special bit of equipment called a light gate. Now, there's 2 of these, one down here, and they're set up to this data logger here. And how the light gates work, when something gets in the way of this light source, it stops the light reaching this sensor here. When that happens, it sends a signal to the data logger to let it know it stopped the light gate. And it's the equivalent of somebody starting a stopwatch. As soon as the object passes the light gate, the light can get through again. It can then send a signal to the data logger, and that's the equivalent of somebody stopping the stopwatch. So a light gate allows you to automatically calculate when to start the data logger stopwatch and when to stop it. So we can have one at the top, one at the bottom. So it can record when the trolley goes past the light gate and when the trolley goes past the bottom light gate. And through that, get a more accurate result. And that will allow you as well to make it more reproducible. So if somebody else did the same experiment, even if they had a different human reaction time, by using a data logger and a light gate, it will make it more likely they get the same result as you. And so that's what we call it, making it more reproducible. So that is the basis for the acceleration practical. Thank you for watching. And make sure you carry out the quiz on EduCkick. Thank you.